We have seen that Apache NiFi is well pre-configured and runs with a very minimal configuration needed out of the box. However, this may get you up and running, but the basic configuration isn't quite ideal for high-performance data flows. Further, a cluster setup or side-to-side connections certainly require a few more settings to be changed. But don't worry, it's still easy to manage, mainly thanks to the good structured and commented configuration files we will cover next, followed by investigating performance-sensitive properties, including best practices for how to configure them. Basically, Apache NiFi has three major configuration files: the NiFi properties file, which we have already seen in a demo, then the Zookeeper properties file, and a file called bootstrap.conf. The NiFi properties file is thereby the main configuration file for controlling how NiFi runs in general. After making changes to this file, it's always necessary to restart NiFi for the changes to take effect. This config file is further divided into different sections, but since there are quite a few, they are here further categorized into their main application areas, which we will work through step by step. The core and state settings is the first category. While the core properties apply to the Apache NiFi core framework as a whole, the state management section provides the functionality of configuring local and cluster-wide mechanisms for components to persist state. This, for example, allows a processor to resume from the place where it left off after NiFi is restarted, or one node needs to overtake the work from another. In the state management section, you further configure whether or not the embedded Zookeeper server should be started. Then the repository settings, which is all about the location and way of storing processed information, including archiving properties. Each repository has thereby its own settings. The web properties section totally pertain to the web-based user interface. Most importantly, the host and port. Remember, this setting determines which URL you must type into the browser to access the NiFi web UI. Then there is a section for configuring side-to-side connections and clusters. While the former governs how instances communicate with remote instances by using remote process groups, the cluster properties need to be set for running Apache NiFi in a cluster. There you can further differ between node-specific settings and properties which should be configured the same way on all nodes. The security properties are quite individual, ranging from authorization and access settings over encryption settings to the configuration of key store settings. Also, Kerberos can be configured as the access management. The NiFi properties file further provides Zookeeper relevant settings used for the cluster management, which brings us directly to the next configuration file, the Zookeeper properties file. This config file serves for the connection between Apache NiFi and the monitoring Zookeeper servers. It holds the fully qualified domain names of all nodes running Zookeeper, regardless of internal or external. The last file, bootstrap.conf, allows to configure settings for how Apache NiFi should be started from a system point of view. This includes parameters, such as the Java heap size or garbage collection. Especially these system-related settings greatly affect the performance of Apache NiFi. While NiFi provides many properties to be set directly in the web UI, there are still several performance-critical properties that can only be set in the underlying config files. For instance, even though NiFi hasn't any work to do since there is no data, it sometimes consumes still quite a lot of CPU. This can be lowered by changing the yield settings accordingly. However, bear in mind that this is going to affect the latency in your current data flow, since by using the default scheduling mode timer-driven, then a processor will be scheduled based on an interval configured in a property called NiFi board yield duration. As we can see, by default this is every 10 milliseconds. This setting can be changed to any desired interval, measured in seconds, minutes or days. The 10 milliseconds already cut down the CPU utilization. So depending on how important latency is to your data flow, increasing this value would cut down the CPU utilization even further. A quite similar usage has the next property, called NiFi administrative yield duration. This is the time preventing a processor to run after an unexpected exception is thrown. Another performance-critical setting is part of the swap auto-disk mechanism. The property NiFi queue swap threshold defines the total number of flow files that can exist on a connection until swapping will occur. If the data flow regularly exceeds this limit, it may be wise to increase this value. Therefore, it's important to also keep an eye on the memory allocated to the Java virtual machine. This is the heap size defined in the bootstrap.conf file that will be discussed in the next slide. The last property you should pay attention to by dealing with a high number of flow files are the indexing settings for capturing snapshots for the provenance repository. If this became a bottleneck, you would even be informed in the user interface with a message that says the rate of the data flow is exceeding the provenance recording rate, slowing down flow to accommodate. However, instead of slowing down the flow, you could also assign more threads or increase the index shard size, which uses more memory and hence results in a better performance. As mentioned earlier, the bootstrap.conf file contains various configuration settings allowing you to optimize the environment of the Java virtual machine, of course limited to the overall server capabilities. If you're interested in the current utilization, this can be found in the web UI under the global menu, then Summary, and then the System Diagnostics pane in the bottom right corner. Also here applies, any changes to this file will take effect only after NiFi is restarted. The first section is used to control the amount of heap memory to use by the Java virtual machine running NiFi. In particular, while the second argument, XMS, determines the initial memory allocation dedicated to the Java virtual machine, the third argument, XMX, is the maximum amount of memory allowed to be consumed. Since these default values are quite small, it's anyway recommended to increase both of them to at least 4 and 8 GB respectively. Also the next setting, the Java virtual machine garbage collection, becomes a very important factor for how well the application runs over time. It tells the Java virtual machine which garbage collection to use during runtime and frees up heap memory by destroying any unreachable objects. Keep in mind that smaller Java memory heap settings may result in more frequent garbage collection being performed. The last section, code cache, is a separate in-memory store that contains all the Java virtual machine bytecode compiled down into native code. Once this is full, the Java virtual machine won't compile any additional code, as the just-in-time compiler is now off and would throw an error message. This will end up with degraded performance. It can either be avoided by increasing the reserved code cache size setting, or establishing a boundary for how much of the code cache can be used before flushing will occur. This prevents it from filling and resulting in the stoppage of the compiler. After this little configuration guidance, we will next dig deeper into the configuration of a cluster.